Welcome back to Cypress Academy PSOC 6 101. In this video, I will show you how to add a capacitive sensing interface to the project we've been working on to provide a local touch interface on the PSOC 6 BLE Pioneer Kit to control the robotic arm. CapSense is Cypress's capacitive sensing technology. It's the same technology that nearly everyone uses every day. It's in your smartphone, your wearable device, your stove, your refrigerator, your smart thermostat. It's everywhere, it really is. It enables designers to remove clunky mechanical buttons and switches, and it really makes a nice, sleek, sexy interface. What's great about Cypress's CapSense solution? Well, it's awesome because it's easy to use. Now everyone asks me, why is it so easy and why does it work so well? And I say, it wasn't that really, we really didn't have to do that much to make it work. It only took us a couple dozen guys, years and years of research development, millions of dollars in chips and software, and a whole boatload of patents. The bottom line is CapSense is built on over 16 years of research and development. It's experts optimizing and perfecting the algorithms and the sensing technologies and the IP. It was all done to make a solution that just works out of the box. Look, don't just take my word for it. You're going to see for yourself in this lesson. Let's start with a new project that I'll call Basic CapSense. In this project, I want to use the capacitive slider and the two capacitive buttons on the PSOC 6 BLE board to act as a dimmer and an on-off switch for the red LED. I'll also use the blue LED to indicate the status of the dimming function. If the blue LED is on, then the dimming is turned off. So we're controlling an LED, so we know we're going to need our trusty PWM and LED setup that we've been using for the last several lessons. So let's just copy and paste that from the basic I2C lesson schematic. We also need an additional digital output for the blue LED. So drag and drop that or copy and paste the red LED digital output pin. Double click and change its name to blue and deselect the hardware control option. Now we need a CapSense component. Drag and drop that into the design. Let's configure that component. Start by renaming it to CapSense, dropping the _1. Now let's add the linear slider and buttons. Click the plus sign, pick linear slider, click the plus sign again, and add button 0, then again for button 1. We'll use the CSX mutual cap scheme for button 0 and 1. Let's pause here for a moment. CSD and CSX are two different types of patented capacitive sensing schemes that Cypress has developed and perfected over the years. CSD is our self-capacitance mode, and CSX is mutual cap. We have lots more documentation and getting started guides, which you can find right here. Next, click on the Advanced tab, CSX Setting, Sub-tab, and set the modulator clock frequency to 12,500. Then click on the Widget Details sub-tab. The two buttons share the same TX pin, so click on button 1 _TX and change the selected pin setting to button 0 _TX. Okay, now let's assign the pins for the two LEDs and the CapSense widgets. The red LED is P03. The blue is P11.1. Because we have both a CSD and a CSX set of capacitive sensing widgets, the scheme requires 3 capacitors that are connected to P71, P72, and P77. The two button RX pins are on P81 and P82. The linear slider is a 5-element slider, so the 5 pins connect to P83 through P87. And finally, the button TX pin is connected to P10. Let's generate the application. All right, on to the firmware. In the CM4 main application, let's start the CapSense component, start the scanning, and turn on the PWM. Now, if our CapSense hardware block is not busy, then we're allowed to ask it what is the state it's in. So check if it's not busy. If it's not busy, process the widgets, find the middle of the finger on the slider, the centroid position as it's known. If it's being touched, as indicated by a value less than 0xFFFF, then we'll set the compare value of the PWM. Since the possible values of the slider are 0 to 100, it matches up nicely with the possible compare values for the PWM. We'll now check to see if someone is touching button 0. If it's being touched, then we'll turn the PWM off and turn on the blue LED. If someone is touching button 1, then we'll turn the PWM on and turn off the blue LED. Finally, we need to update the baselines, which represent the environment that the board is sitting in. This is where some of the magic happens. You want your board to be robust, regardless of the temperature, humidity, location. And don't forget, there's also the other manufacturing variances, how thick the printed circuit board is, how thick the overlay is. All of these things are key in making your wearable and your IoT device work well with CapSense, and we do it automatically. Now we need to start the scanning again. All right, that's it. Let's build, program, and test. Hey, look, when I move my finger on the slider, you can see how the intensity varies. And when I push on button 0, that blue LED turns on and the slider is disabled. And when I push on button 1, the red LED is back on again, and I can use the slider to vary the LED intensity. Now we have the basic CapSense implementation working. In the next video, we'll add this functionality to the BLE-controlled robotic arm project. As always, you can post your comments and your questions in our PSOC 6 developers community, or you're welcome to email me at alan_hawes@cypress.com or tweet me at AskIoTExpert. Thank you.